we're going to do some of these. This is from the worksheet, just more practice on exponential functions, writing them and using them, and we're going to work through some of the odd problems. So we're supposed to write an equation that matches this table, and that equation may be in this form if this data is exponential. Okay, so what we need to figure out is, from here to here, is there something that we've multiplied to get from 300 to 150? And a lot of people will say that's divided by 2. Dividing by 2 is the same thing as multiplying by 1/2. So if you have like 4 divided by 2, what is that? That's 2. But 1/2 times 4 is also 2. It's the same thing. So we are multiplying by 1/2 to get from 300 to 150. And then to get from 150 to 75, multiply by 1/2 again. And then we multiply by 1/2 again. So this right here is called a constant multiplier, and that is your b value. So b in this equation is the 1/2. Then we've got to know what a is. What is our starting point? And that starting point is the y value when x is equal to 0. So there's one way to write this equation: 300 times 1/2 to the x. Okay. So if you think about putting in a 0 right here for x, then that's going to be 1/2 to the 0, which is 1. 300 times 1 is 300, so that gets you the first value. If we were to put a 2 in here, then that would be 1/2 to the second power would be 1/4, and then so you would do 300 divided by 4, which is 75. Okay, so that equation models all of the data in our table. Let's jump over and do number 3. So number 3, we've got this graph, and again we need to write the equation for the function that we see here. Okay? So if we want to do that, if we want to write the equation, we need to know what kind of function is this, and then what are the important points for this function. So if it's quadratic, you want to know the vertex. If it's linear, you want to know the slope and you want to know the y-intercept. Okay, so this one, I'm going to look at some of the points that we have here. I'll just take those 4 out of there. We'll look at those. We'll kind of create a table like we had in problem number 1. When x is -1, y is 8. When x is 0, y is 4. When x is 1, y is 2. 2, y is 1. We could keep going, but those are the ones that we can get that are on those grid lines. And so what's happening from here to here? Just like number 1, we're multiplying by 1/2. Okay? Times 1/2. Okay, so that's our constant multiplier. Y equals, we have 1/2 raised to the x. And what was our starting point? It's this one right here. When x is 0, y is 4. So 4 times 1/2 to the x. Now both of those problems are exponential decay, but something like number 4 is exponential growth. So you would do the same thing, find the multiplier, find the y-intercept, which looks like it's 3 on this one, and then you write your exponential equation. Okay. Number 5, we've got an example of interest that's being compounded. So compound interest, and it says that we're compounding semi-annually, so that's just twice a year. Semi-annually, 2 times per year. They tell us 5% interest rate. Okay, let's focus on the question. What will the account balance be after 6 years? So they're asking us for this, and I'm going to use the equation on the left instead of PE to the RT, because this one's only for, this is for compounding continuously. Continuously. All right, so we're using this first one. We want to know the account balance A. So what do we start with? $4,848. Okay. If you have $4,848, just throw it in the bank. 1 plus, what's the rate? 5%, 0.05, divided by n. So that's not the number of years, it's the number of times we compound per year. So that 5% is a yearly interest rate, But we have split it up into two sections, basically. 2 times is how we get this interest. And then we need to say, well, then how many times are we compounding? 2 times per year for 6 years. That's our T. So there's 12 times we compound this interest. We don't get 5% every time, we get a portion of that divided by 2. Alright, so you plug all this into your calculator. And I'm going to show you this 4,848 times 1.345. So this right here is your actual percentage gain over the course of the 6 years. You gain 34.5%. So if you look at the 5% per year for 6 years, that would be 30%, right? But we are gaining actually more than that because our interest is gaining interest, compound interest. And when you multiply all that out, you get the amount is $6,520.02. Keep those pennies. We'll do also number 7 on this video, and that'll be it for this one. Again, we have another compound interest problem. It says 3 times per year. Okay. So this would be every 4 months. Not to be confused with quarterly, which is every 3 months, 4 quarters in a dollar. So again, we're going to be using the compound interest equation on the left here. This is not continuous, but they want to know the amount of the initial investment. They're asking us for P. Right, so we know the final amount. We reach 5,485.85. We don't know what we started with yet. We know that our rate was 0.0461. Okay, that's 4.61% as a decimal, divided by 3 raised to the 3, and it took us 6 years to do that. Okay, so now we just need to solve for P. So I'm going to convert the 1 plus 0.0461 divided by 3, and I'm going to raise it to that 18th power to get, we'll call it 1.316, so 31.6% gain, and then we're going to divide both sides by that 1.316. And the answer that I got here was $4,168. Uh-oh. I'm going to have to re-round. It's 99.8 cents, which is $1. So $4,169.00 is what we started with. Alright, more to come in a new video.